Prove the cosine rule a squared equals b squared plus c squared minus 2bc cosine a in the case where a is obtuse. To prove identities or theorems or rules, we recall previous learnings and use them creatively. Let's draw an auxiliary line here to create right triangles. This would allow us to apply the Pythagorean theorem. I can actually see two right triangles here, this, and the bigger right triangle right here. Okay, so B, the side B here serves as the hypotenuse of the smaller right triangle. So applying Pythagorean theorem, we say that b squared equals h squared plus x squared. Okay, another right triangle. A serves as the hypotenuse. A squared equals h squared plus x plus c, the bottom side, square. Okay, so we already have two equations. The next thing we have to do is, of course, I want to get rid of that x here and just make an equation in terms of the letters from the original triangle given. We can recall the trigonometric ratios. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, or tangent equals opposite over adjacent. In this case, let's use cosine because this angle is 180 minus a, and adjacent to that angle is x, and its hypotenuse is b. So we can actually create another equation in terms of b and angle a. All right, so let's say cosine of 180 minus a equals adjacent x and its hypotenuse b. So we can say that x is equal to b cosine 180 minus a. But we also know the concept of the supplementary angles of cosine. If you try to recall that, we can say that okay, because I just want to adjust this equation to a simpler one. So as we know, the cosine of an angle is equal to the negative cosine of its supplementary angle. Let me write it here. So cosine 180 minus a is equal to negative cosine a. Okay, so instead of this, we can say that x is equal to b times the negative of cosine a. Or simply, x is negative b cosine a. Okay? So let's put them all together now. So we have three equations. I'll just number them for reference, for ease of reference. Okay? Now, I want to use equation number 2 because it's closest to what we are trying to prove the cosine rule. So let's go back to equation number 2, and I will expand x plus c squared. Okay, so I'm referring to this. Let's write it here. We have here a squared equals h squared plus, what is x plus c squared? So that's x squared plus 2xc plus c squared. Okay? And we know that, what do we do next? Maybe let's use equation 3 and substitute this here. Okay? I can also use equation 1 to use b squared instead. So because as I've said, I want to just limit my letters or variables to just the letters given in our original triangle. So a square, we know that from equation 1, h squared plus x squared is b squared. And this is 2, what is x? X is negative b cosine a, and c plus c squared. Okay, so a squared equals b squared plus c squared. This is negative minus 2b, this one, and this one, c cosine a. So this is what we're trying to prove. We're able to prove it, and it shows how math builds on its own.